So tonight we're going to talk about literal equations. Now, I want to warn you, this can be a fairly taxing lesson. Literal equations are going to be equations that have more than one variable, and we're going to solve for a very specific variable. You do these as far as formulas in science, so I'm sure in the past you've learned like D equals RT, and then you learned, your triangle, like this, D, RT. So you can see that you can do rate equals distance over time, and you can also do time equals distance over rate. And these are all three formulas representing the same thing. We're just solving for a different variable, and this little triangle helps us see that. So what we're going to do is we're going to use our algebraic steps to see why this works. If you start to feel frustrated, just take a deep breath. We're going to spend a couple of days working on this because it can be a little bit difficult because we're used to using just numbers. So we have a formula that describes how two or more quantities are related. Geometry, physics, economics, and so on. Lots of geometry. So, for example, when you did C equals pi times V, or A equals base times height. This is a literal equation. You use them often, but you're used to plugging numbers in to be able to solve it. So we're going to look at what happens when we're not plugging in the numbers, we're just solving for a variable. So here is an equation, 4x plus b equals 12, and we want to solve for x. Now, I'm going to write it separately over here so you can see, because when they do their steps, they do it horizontally, and we're used to doing it vertically. So they want us to solve for x. So I would suggest to you that you either circle or you highlight that variable that you want to learn. And we're going to go through those same steps that we've been doing. So there's no distributing, there's no collecting like terms, there's no variables on both sides. This is simply undo the add subtract. Now remember, we want to get this variable alone and positive. Well, what's happening to it? We're adding b. What is the inverse of a plus b? Well, it's a minus b. If it makes you feel better, it kind of looks like a 6. If it was a positive 6, we would subtract 6. Okay? The only difference is when we get to this side, these are not like terms. If it was a 6, we'd put it together, we'd write 6, because 12 minus 6 is 6. But they're not like terms, so we're just going to write them next to each other. 12 minus b, which is exactly what this is saying. This last step we've been discussing is to undo the multiply divide, or do the inverse. Here we're multiplying by 4, so the inverse is to divide by 4. And you need to divide everything by 4. 4 divided by 4 is 1. 1x, that's what we want. 12 divided by 4 is 3. Now this we cannot simplify, so we're just going to rewrite it. And that's how they got this. So we're going to work through several of these, and I want you to take your time and really think about those steps. If it helps for you to have your journal out where we wrote them, then we can do that. I'm going to actually work over here in the margin so we have space. So we're going to do a couple of these together. So ax plus 7 is equal to 3. And again, we're solving for x. So remember, you want to get rid of whatever is being added or subtracted to the variable, and then secondly, undo what's being multiplied or divided to the variable. So we're going to say, okay, we're adding 7. So the inverse of adding 7 is to subtract 7. Bring down what we have. Ax equals, well, we can do 3 minus 7. Those are like terms. We can put those together. 3 minus 7 is a negative 4. Be very cautious with your signs, please. And now we are, highlighted on the other one as well. Sorry about that. We're multiplying, so the inverse is to divide. What you divide on one side, you divide on the other. A divided by A, anything divided by itself is 1, which is what we want. 1x equals. We can't do anything with this. We don't know what A is. So we're simply going to write negative 4 over A. And that's how we get x by itself. Now, if we eventually knew what A was, we could plug it in and we could figure out what x would be. On letter B, again, we're looking for x. Cx minus 10 equals negative 5. So what's happening to x? Well, we're subtracting 10 from x, so the inverse of that is to add it. Cx equals negative 5 plus 10 is positive 5. And now we're multiplying by c, so the inverse is to divide by c. C divided by c is 1x equals, we can't do anything with 5 over c, so we're going to leave it. What I would like you to do is I would like you to try letter C, and I'm going to put that on the Google form for you to look at a couple of different multiple choice answers so you can choose which one matches your answer. So we'll do that part of the Google form after the video. Now, on this next page, just so you can identify, is the equation 2x plus 4 equals 5x minus 6 a literal equation? No. A literal equation is going to have more than one type of variable. So this only has the one variable. We are going to solve them the same way. Down here, we've got a science equation. V equals V sub O plus AT gives you your velocity after t seconds. VO is the initial velocity in meters per second, and A is the acceleration. Again, this is a little bit confusing, so I'm going to come over here on the margin. I'm going to rewrite this so you can visually see what's happening without all of this stuff in the way. So this is example B. V equals, we call that V sub 0, or the initial velocity, plus A for acceleration times T, the time. So this is asking us to solve for A. So I'm going to go ahead and I'm going to highlight A. And remember, we're going to, none of these are like terms. We're not going to be able to put any of these together. None of these match. So we're still going through our steps. The inverse of adding and subtracting. Well, this is being multiplied by t, so we're not going to be there yet. We're going to be looking at v sub 0. It's a positive, so the inverse is to subtract it. So v minus v sub 0, because these, again, are not like terms. Even though they look the same, they have a different subset. This is technically a 1 and that's a 0. Equals a times t. So now, undo the multiply divide. So we're multiplying by t, so we're going to divide by t. And we can write it, because we're not going to be able to simplify any of this. Before we had 12 over 4, so we knew we could simplify. You can write it like this. And that's where they came up with their equation below. You could technically, if you wanted to write it the way we did before, you can write both of them divided by t, if you preferred that. Both of them, they mean the same thing. You just can write it differently. Last one I want to do, we have a table here. And on this table, we have a lot of different equations that we normally see. So I'm going to have you put in your distance one. We're going to do this one on the Google form. But I want you to look at the pressure. I'm going to go ahead and I'm going to write this in the margin as well. So P equals F over A. And it tells you pressure on surface, force applied, A is the area of the surface. That really doesn't matter to us. What matters is that we want to solve for F. Now this can be a little bit tricky, so I'm going to give you one with numbers. If I said 10 equals X over 5, I want to know what divided by 5 is 10. Well, we're dividing by 5, so the inverse is to multiply both sides by 5. The same thing is happening here. We're dividing by a, so we need to multiply both sides by a. You can put a 1 here if you wanted. So f is equal to a times p. So sometimes if you feel like you can plug in some numbers and kind of visually see what's happening there, then by all means do that. The other one I want to do with you is this kinetic energy. And I want to talk to you about this 1/2. So 1/2 means that you are dividing by 2. So we can do this a couple of ways. I'm going to rewrite this as mv squared over 2. Because technically, I could put my 1 there. Here's my m. So just like before, we need to get rid of a dividing by 2. So we're going to multiply by 2. 2 times k equals mv squared. That 1, remember, 1s are invisible in algebra, so we don't have to write it. And now we're multiplying. So the inverse of multiplying is dividing. That squared, it goes with the v. So m is equal to 2 times k over v squared. I realize this is a little bit taxing and it's a little stressful because we're using all letters instead of numbers, but we're going to practice this some more in class tomorrow. So just take a deep breath and we're going to get there together. Have a good night.